Right. Hello, everybody, to our last little session where we wrap up part two of this course. Now, let's just sort of review a couple of things that we did and check that my sound is working and everything. Okay, yes. We did a couple of things that I just want to remember. When we looked at our probability distributions, we talked about the expected value where, and this was the one of the games of chance that we did, the last one, where we had different outcomes and probabilities, theoretical probabilities that we could calculate, a theoretical ideal, and then the expected value is a measure of, well, what we expect, as well as what we expect in the long term, how this is going to behave with many repetitions of the experiment. Okay, so I just want to remember that. Then we talked about different ways to sort of measure the center of a sample by way of an average, and sometimes if we have extreme values called outliers, the average, the mean is a little deceptive, so the median is there for backup purposes. There's one other kind of average that is related, but I didn't quite have time to talk about that and give it the attention that it deserves, and that's the weighted average. Now, some of you might know uh, this term already, but of course I don't assume that you do. So let's just look at an example here. Suppose I work two jobs. In the first job, I work 2 hours at $15 an hour, and in the second, I work 4 hours at $10 per hour. So that to the side here, just a little example here. No specific exercise just yet. So my sample of hourly income, I guess I could call it, is really $15 for the 1 hour, $15 for the second hour of those first two. Then at the other job, I work for 4 hours and I get $10, $10, $10, and $10 an hour. So then the mean or the average, whichever word you want to use, is okay at our level, is then simply add them all together, 15 plus 15 plus 10 plus 10 plus 10 plus 10 over how many there are. And there are, of course, 6 of them. So let's calculate that. See it in the chat here. 15 plus 15 plus 10 plus 10 plus 10 plus 10 divided by 6. And we get an average of $11.67, let's say. Now I can look at this a little bit differently because I can imagine that if I worked for more hours in the first job, I still get $15 an hour. So I'll have these 15s, just many, many, many of them, and maybe many of these 10s. It seems silly to list them all when they're pretty much the same numbers. So what I could do is just rewrite this to 2 times 15 plus 4 times 10. And then I also want to see, where does this 6 come from? The 6 comes from the fact that there are 6 of them, yes, but because there are 2 of these, and 4 of those. So it comes from 2 plus 4. So of course my answer is going to be the same. It's the same. But seeing it like this is just a little bit more convenient in case the situation blows up and I work for many hours at job 1, many hours at job 2. This version of the calculation doesn't really blow up and I have to list a whole bunch of numbers. If those numbers are the same, I can group them together. So this 2 and this 4 we call the weights. It tells me which one occurs how many times. There's a weight associated to it. The second job carries a higher weight because I work more often at that job. It has a bigger role in my average calculation. And this, well, I struggle to do a curly bracket that way, is called, the whole calculation is called the weighted average. And it's not a new calculation. It's simply a more convenient version when things repeat themselves. When things repeat themselves. And it opens up more connections and just more efficient ways of looking at this average. I just want to double check if I do have another exercise I might have just forgotten about. No, not yet. Okay. So I want to get to exercise 8.2, but not yet. So it's important people think of the weighted average, and I understand why. Sometimes it looks a little different. Sometimes you don't see this connection because there are more numbers and the weights are maybe not as obvious, but it is still the same average calculation, just in a more convenient, compact form. So if I go back a couple of sessions to this game of chance where I rolled double 6 and I win $10. I roll any other double, I win $5. I roll anything else from 2 dice and I don't win anything. I'm just picking this one because it didn't have too many options. Actually, no, not this one. That was to remember the expected value formula, right? The expected value formula, I didn't have many options, so it's not that long. The expected value formula is take each possible outcome and multiply it by its corresponding probability. Next pair, calculate. Okay. So there is actually a connection between expected value and weighted average. Now there's more than one way to do this, but this is maybe the easiest to understand. Okay, so let's look at this situation, this example that we did, where we rolled we rolled 2 dice as well. We looked for the largest of the two numbers, and we used that to discuss the difference between a theoretical probability distribution and the actual practical side of things, that when I actually do this experiment a few times, I'm not getting these exact probabilities. They're theoretical ideals, long-term ideals. I'm going to be a little off, but the more I repeat the experiment, the closer I'll drift towards those theoretical ideals. So then we did it just sort of hypothetically, and we rolled our 2 dice 100 times, if you remember. And if you don't, you should watch those first and come back to this, right? We rolled it 100 times, we got these numbers, and then we got relative frequencies, and so on. And I claimed at that stage, without showing it, that these relative frequencies can then be used to approximate expected value as well, because these relative frequencies approximate the theoretical probabilities by just having enough examples, enough repetitions rather. So let's just note here a weighted average for this situation. Well, a weighted average would work in this case if I just average out everything that I got, right? I got the outcome 1 2 times. I got the outcome 2 5 times. I got the outcome 3 20 times, and so on. So this works exactly like this example. It's not dollar amounts, but there's a certain number of times things occurred. So instead of adding up 100 of these numbers separately, I can group them by seeing the number of times it occurs each time as the weight of that outcome. So the weight of the first outcome is 2 times the outcome itself. I'm looking for the average outcome. These are the outcomes, 1 to 6. And the weighted average just gives me a more convenient way to write down this calculation. 5 times the outcome 2 occurred, so 2 has a weight of 5 in my sample of 100. 20 times the outcome 3 occurred, 25 times, I don't know if I'm going to squeeze this in. I think I'm running out of space. Back it up. I need to be a little more squishy from the start, it seems. Not doing anything new, just space management. The weight of 3 is 20. The weight of 4 is 25. The weight of 5 is 30. The weight of 6 is 18. Then, of course, I have to divide by the sum of all the weights. Here, sum of the weights. Now, in this in these cases, I know I have 100, but I'll just emphasize the 100 comes from adding up all these weights. And in other cases, I might not care to add that up separately. It is built in. It's always going to be the total. Let's see what we get. Let us do it. Now, for the calculation purposes, I can make the 100 denominator nice and compact, of course. Let us do it. Oopsie, 2 equal signs. 2 times 1 plus 5 times 2 plus 20 times 3 plus 25 times 4 plus 30 times 5 plus 18 times 6. Close the bracket, divide by 100. Hopefully I did that right. I did not. What is your pickle, MathBot? MathBot is unhappy about the fact that I did not open my bracket, yet I close it. Now it is much happier. Okay, good to know. 4.3. So for this sample, the average, this is still a mean, this is still the mean, sample mean, measure of center of where this sits without looking at the probabilities of what I think. Ooh, yeah, here in the middle seems to be the likely. See, if I draw the histogram, the bars should be higher here in the middle, but I don't know exactly, right? 4.3-ish. So around 4, 3, 4, 5s, those are the ones I expect more often than the others, and the probability, then the relative frequencies confirm that. But I don't know exactly how these combine to have one number represent the whole thing. That's where the calculation comes in. Now, let me just see this calculation. And I'm actually going to now merge this into 100. Erase with a very small eraser. That's good enough. Make it 100. Now, if you are comfortable with fractions, which we all should be, we can write all of these terms in the top over the common denominator of 100. So then we have 2 times 1 over 100 plus 5 times 2 over 100. I'm just doing this to show the link between, well, what I want to show without ruining the whole thing. I won't say it in advance. Separating over common denominator. Now within each term, I'm going to just write this guy separately in front. So it's going to be 1 times 2 over 100 plus these guys, these second guys, the outcome values. 2 times 5 over 100. Why am I doing this? Give me a second and you will see. 20 over 100. No. 4 times 25 over 100 plus 5 times 30 over 100 plus 6 times 18 over 100. And it's still the same, right? It's still the 4.3 answer. Now, if I make the connection between this and looking at my table, it's a little hard to see all of it. Let me try and zoom out. We see that this calculation here uses the outcome values paired with their corresponding relative frequencies. And the relative frequencies are what serves as the probabilities. So here I have an approximation to the expected value. So the expected value, remember this, number times probability, number times probability, number times probability, but I don't have the theoretical probabilities. I use the relative frequencies as the theoretical probabilities, right? It's the closest I can get. That's all I have. So it's an approximation to the expected value. The calculation looks exactly the same. So a weighted average is, well, let me rephrase that. So an expected value is really a weighted average. Now, some of you might say, well, yeah, of course it is. I can see different kinds of weights here, but the average isn't quite obvious because I did say at that stage that the outcome values are weighted according to their probabilities, but it doesn't quite seem like a weighted average in the same way. So I wanted to make that connection that the conventional weighted average calculation when it comes to a sample is an approximation. That mean, that sample mean, 4.3, is the expected value approximation. That's what we're trying to say. So these things are the same. And in statistics, the expected value is called the mean because they are the same thing. So these things have connections and they are often sort of different um, faces to the same thing. I thought that was interesting. Now let's get to something even more practical and relevant to our current situation by way of exercise 8.2. Now I will say from the start, I'm not doing all of this because I think some of them are just duplicating previous numbers, but we'll do like three of them. I think I'll leave out uh, number 3 maybe. We'll do 1, 2, and 4. In Math 143 grade calculation, might be a little different than ours, but pretend this is how our calculation goes. The quizzes contribute 40% in total to the final grade. Assignments contribute 10%, and the final exam contributes 50%. In number 1, let's just read number 1. Johnny scored 80% on his quizzes, 30 out of 40 on his assignment, and 82% on the final. What is his overall percentage? Now, the beauty of weighted averages, and your percentage in the end is an average of all these things combined, right? The beauty of weighted averages is the weights don't have to necessarily be explicitly the number of times things occur in a sample. It can be a lot of different things. So in this case, let's just say in general here, so I don't flip back and forth, the quizzes or the quizzes overall, I guess quizzes overall have grammar, have weight 40% or just 40. I can say 40%, doesn't matter. The assignment, let's say the homework, and I think there's only one. So has, I don't know, the average of all the homework together that has weight 10%. And the final exam has, there's only one final exam, I hope, weight 50%. There is just a weight associated with it. In some cases, it's a repetition, a number of times. Doesn't have to be. In this case, it's a percentage. Okay, so just have that block there so we don't forget. Now in number one, I have different scenarios. So what did Johnny score? So Johnny, in his quizzes, his quiz average on its own is 80%. His homework is, well, I want to know what his homework is because they tell me it is 30 out of 40. So I want these units, so to speak, to all be the same, right? So if I'm working with percentage, they should also be percentage. And the final exam was an average 82%. So I just need to convert the 30 out of 40 to a percentage. You can just multiply, oops, where's my pen? Multiply by 100 and of course get 75%. Eraser mode. I'll fill in the 75% there. So they're just trying to trick me by giving me some actual test scores, some percentages. I need to make them the same. And I choose percentages for their convenience. They want to know what is his overall percentage. His overall percentage is then just for all a weighted average. Weighted average. Now, on purpose, I don't write percentages here for the weights to try and tell them apart. So people get confused if I write percentages everywhere. But there are these numbers at the top, which I consider the weights, and then this is his actual score in percentage points, so to speak. So there's a difference. So I don't write percentages everywhere to help me remind myself that they have different roles in the calculation. So I have a weight of 40 for his quiz scores, altogether grouped just the quizzes. A weight of 10 for his homework. A weight of 50 for his, squeeze it in, his final exam. Weighted average, of course, divides by the sum of the weights, which, yes, I know, it should be 100, right? Then we'll calculate that. And my unit, in a way, is percentage, so my answer will be a percentage. Let's see what he got for his overall grade or percentage. 40 times 80 plus 10 times 75 plus 50 times 82 divided by 100. Hopefully this time MathBot likes me. 81.3%. Now I like this example because obviously it's relevant. Obviously it's important. And a shocking number of people cannot calculate their own grade. And I feel that if you're going to take a course, any course, doesn't have to be this one, anything, that's an essential skill. That's an essential skill. And then people say, yeah, but there's an app for that. I don't need to think. I don't really have a comeback to that other than personal pride and responsibility. I feel it's an essential skill. Agree to disagree. So, the straightforward version of this is where I pretty much know the scores, if you will, percentage scores for each of the components, and then the breakdown serves as the weight for each weighted average calculation. So there are other ways to do this, maybe slightly more intuitive ways, but I want to connect this to a weighted average calculation. It is the most compact and efficient way once you understand weighted averages. But no, if you have your own way of doing this systematically and it makes sense to you, my goal is not to overwrite this. My goal is to give an application for weighted averages that is as relevant as we can get. So let's read the next one here. I'll do number 2 and then number 4. Number 3 is, you can see that as an extra little practice problem. It's not anything new. Jani scored 16 out of 20, 4 out of 20. Ooh, that's a bad quiz. 19 out of 20, 14 out of 20 on her quizzes, 80% on her assignment, 40 out of 65 on the final. What's her overall percentage? Okay, so it's the same goal. I only need to sort of work with the numbers a little bit to get it where I want. So I can squeeze it in here, but I'm not going to. Our weights are the same. We just need to see here, what is Jani's quiz average? What's her quiz score? That might need some work. What's her homework score in percentage? What's her final score in percentage? I say average, but I'm really just getting the number for each of these components for convenience. I could split this up further into a quiz one, but then my list gets long and there's no benefit to that. An average of an average is still an average, luckily. Uh, so for this quiz average, I need 16 out of 20, and I can make that a percentage. Perhaps that's the most intuitive for people. I can take the 4 out of 20 and make that a percentage. I can take, let's maybe not do a plus right here. Let's just list them. I can take the 19 out of 20 and make that a percentage, because percentages are there to be convenient, right? They, to me at least, are intuitive and easy to work with. So if I can go to a percentage, I'm going to. So I want percentages for each of those. This is, again, just one way to do it, not necessarily the only way. So 16, I don't want to guess. 16 out of 20 times 100. I thought it was 80%, but now I know for sure. That's 80%. 4 out of 20 is a fifth. That's 20%. 19 out of 20. Let's see it in the chat, right? You don't have to know these. 20 times 100. 5. So each is a fifth of each score out of 20 is 5%. 15 out of 20 times 100. So it's just a little less convenient with them giving me the scores. So now I need to put all these together in an average. Well, that's just my basic average of adding them up, which is still a weighted average. They just occur once, so the weight is 1. Again, not the only way to do this. We're looking for the most efficient way here. So we get, oh, I need to calculate it. Haha, that might be handy. 80 plus 20 plus 95 plus 70, close bracket, divided by 4, and we get 66.25% for her quizzes. Now, I don't remember what was the homework situation. Oh, they give me a nice percentage there, so no work to be done. And then 40 out of 65 for the final. Okay, I'll just make that a percentage real quick. That's not too bad. Let's see what that is. 40 out of 65. Oh, I forgot my 100, but it will be 61.54%. Now, admittedly, we shouldn't round this too early. We have to remember that this was not the accurate number, 61.5384615 blah blah blah. At least if I have a good number of them, then I'm not going to lose too much because I'm rounding my final answer to 2 decimals. So I don't want to round in the meantime to that same position, then I could lose that decimal place. Okay, so overall I have a weight of something I don't remember, 40, right? A 40 weight for quizzes, a 10 weight for homework, a 50 weight for, I'm going to write 61.54, but understand that in the calculation, use the accurate value. And that, of course, adds up to, oh, sorry, is divided by the sum of the weights. Let's do this thing. 40 times 66.25, that was accurate. 10 times 80, 50 times 61.53846,153 should be enough decimals. Divided by 100, and we get 65. Now, this is my final answer, so I'm going to round this guy to 27%. Weighted average. Enable yourself. Calculate these things. Let's just go back here and show this. I took it away a little bit too fast, perhaps. But in the video, you can always pause. So that's the convenience. Okay, so like I said, I'm going to skip number 3 because it's just more of the same, really. See it as another problem to practice on. But number 4, maybe not so much. A little bit different, perhaps. If Tammy scored an average of 75% on her assignment, with 18 out of 20, 18 out of 20, 16 out of 20, 12 out of 20 on her quizzes, what should she score out of 65 on the final to end with an overall percentage of 60% or better? See, that's a little different. So they give me the overall percentage and ask me what should happen in the final exam. Okay, not quite ready for that. I will be soon. I'm not quite ready. Let me lay this out in a way that's as similar to what we did before as possible. Homework, final. Okay, so the quiz average, I have to do that as well, right? So I have 18 out of 20, 18 out of 20, and if you sit, oh, sorry. Well, I can do it. I can do it like that, yeah. If you sit there thinking, well, there's a faster way to calculate the quiz averages, I know there is, but I'm looking for a way that makes the most sense if you have no idea what to do. That's always the goal here. So we learned from the previous one that if the test is out of 20, there's a shortcut that each point is worth, each mark, I guess, is worth 5%. So 18 out of 20 is 90% because I lost to 90%. So I lost 4 here, so that's 80%. And we've seen that here as well, 80%. But if it's a different weird denominator, then of course, who knows? I lost 8, that's 60%. Of course, verify that with your calculator. And now I'm going to average these out and divide by how many there are to get, I don't know what I get. Definitely need a calculator for that. 90 plus 90 plus 80 plus 60. She was slipping a little at the end there. Gives us a very nice 80%. Now, are they nice enough to give me the homework? Yeah. 75. The final exam? I have no idea. That is what I'm looking for. So that's my question mark. Put it in a box. My label for the thing I want. But nothing changes. overall, my calculation is still the same. Overall, I'm going to have a weight of 40 for the quiz percentage, a weight of 10 for the homework percentage, a weight of 50 for the final exam percentage. Just don't know what it is. Totally fine. 40 plus 10 plus 50, always divided by the sum of the weights. Now I know this must equal 60% as a bare minimum, right? Of course, then if I have a higher final exam score, that'll be higher. So I don't need to worry about an inequality here. Go for the lowest, because if one goes up, the other goes up. It's easy to interpret that at the end. Of course, here I can merge these, be 100. Make my life a little simpler before I copy everything over and bore you to tears. 100. So now my goal is to figure out what the question mark value is. You can guess and check your way through it, but that might take some time. Having some basic knowledge about variables and equations in algebra, oh, it's handy. So I'm going to multiply both sides by 100. 40 times 80. Oh, I kind of need to calculate this. Yeah. So oops. I'm going to do multiple things here. I'm going to multiply both sides by 100. So the right-hand side is going to be 6,000. I write the unit. Keep track of the unit. It's good. Units are good. Though, if it bothers you, we can leave it out. It might bother some people, to be honest. Some people are okay with leaving units in an equation. Some people leave it and just write the units at the end. We're not doing physics or anything where tracking units can be quite tricky sometimes, so we'll be okay. So I'm going to multiply both sides by 100. That gets rid of this denominator here and multiplies the other 60 by 100. And then I'm going to calculate some of these multiplications. So 4 times 8 is 32, so 3200. 10 times 70, and then 50 times my question mark. I can't quite simplify because don't know what question mark is. Then I'll add these together for 3950. Then we subtract 3950 on both sides to get 50 times question mark equals 6,000. Let's do it like this. 39. Can you not write a 9? Come on. Subtract 39. Oh, my 9s seem to struggle. It's good practice to do that in your head, right? Yeah. It's 2050, right? Because we're 50 away from 4,000 and then another 2,000 to get to 6,000. So 2050. Then I'm going to divide both sides by 50. So question mark is, and remember this is a percentage, that's the unit of the sample values, if you will. So what is this? The zeros cancel. 205 is 41, right? Because 5 goes into 24 times, and then 5 goes into 5 one time. 41. That's not the answer. Always check the question. That's this guy. That's your final exam percentage. That's not what they actually asked. It's close. It's not actually. They asked, what should she score out of 65 on the final? I know her final percentage, her final exam percentage should be 41%. So I could say that over here. Oops. Her final exam percentage should be at least, because that's our bare minimum, 41%. Calculation to make this a score out of 65. So let's say here in line, since 41 over 100, that's a percentage, applied to 65 is, oh, I don't know what that is. Let's see. 41 divided by 100 times 65. Of course, we have to have a basic proficiency in percentages. Of course, 26.65. That is not a percentage. That is a score out of 65. She, was it a she? Yes. She should score at least 27 out of 65 on the final. These are extremely important things. How many times or how many people have gone into a final exam and wondered, what I want to get to 60% or I want to get to 80% or 90 or whatever. What do I need to get on the final? That is a question that every student, almost every student has. Super important. Enable yourself. Oops, that's too small. It's 33. I want 33 zoom. There we go. Enable yourself with the skills to answer these questions for yourself out of pride. Be responsible for your own learning, right? That's one of the hints. Studying. It's good. It's important. Brain doesn't turn to mush. All right. Now, I may or may not have said that this was going to be a Q&A session. Turns out we needed more time. In hindsight, my initial scheduling wisdom knew that this was going to take this many sessions. I should just trust myself. So there are 7 minutes technically for questions, so feel free to ask questions. But if no one says anything, then we will cut it here and start our long weekend and reading break. Try and not do nothing over reading break because I find it really hard to come back after reading break. Whew. It's tough. Let's have a look at some problemos. We can do them all. They're all wonderful. They are all wonderful things. All beautiful, beautiful questions. All of them. Every single one. Do them all. Do them all. Of course, you see the ones that closely resemble exercises. Raffle, balanced dice. Oh, great calculation. You can start with those when they are obviously or very closely related to exercises we've done. Start with those. But they're all good and wonderful things. All right. There seem to be no questions. So then I bid you adieu and enjoy the long weekend.